Every great city begins with a single, humble foundation, a solitary stone laid upon the earth, a promise of what is to come. For the coral reef, a metropolis of breathtaking scale and complexity, that first stone is not a stone at all. It is a dream. The dream of a single polyp. A coral polyp is a creature of profound simplicity. To the naked eye, it might be mistaken for a tiny, delicate flower, a blossom of the sea. It is soft, gelatinous, and so small that you could hold a dozen of them on your fingertip and still have room to spare. Imagine a living vase no larger than a grain of rice. A simple, sac-like body with a single opening that serves as both mouth and, well, the other end of its digestive tract. Surrounding this opening is a graceful crown of tentacles, fine as silk threads, which sway in the water with a hypnotic, rhythmic patience. This is the architect. This minuscule, soft-bodied being is the master builder of the grandest structures the living world has ever known. But an architect needs materials, and so the polyp performs a quiet miracle. It begins to draw dissolved calcium and carbonate from the vastness of the sea around it. It takes these invisible floating minerals and, from within the very tissues of its own body, it weaves them together. It secretes a substance that hardens into a sturdy, protective limestone cup, a tiny, sculpted chalice that we call a corallite. This is its home, its fortress, the first brick in the Great Wall of the Reef. Within this stony cup, the polyp can retreat, hiding away from the world when danger whispers by. It is a sanctuary of one, a single calcified room in a palace that has not yet been imagined. But a home, however safe, is not enough to sustain a dream. A dream needs energy. It needs light. And here, the polyp holds its most beautiful secret, a secret partnership woven into the very fabric of its being. For living inside the soft, transparent tissues of the polyp are millions of microscopic, single-celled algae. Their name is a gentle, flowing word, zooxanthellae. These zooxanthellae are sun farmers. They are tiny, plant-like organisms that bask in the sunlight that filters down through the clear, blue water. Within their own microscopic bodies, they perform the quiet magic of photosynthesis. They take the sun's energy, they take carbon dioxide from the polyp, and they transform it into simple sugars, nourishment. And in an act of boundless generosity, they share this sugary fuel with their animal host. They feed the polyp that houses them. In return, the polyp offers a safe haven, a place bathed in sunlight, nestled in its stony cup, where the algae can live and thrive. It is a perfect silent exchange, a friendship so fundamental that it is the very heartbeat of the reef. The polyp provides the structure, the architecture of stone. The zooxanthellae provide the color, the food, the vibrant energy that paints the reef in hues of ochre, mustard, and deep forest green. It is this partnership that allows the reef to thrive in the nutrient-poor, desert-like waters of the tropics. It is a self-contained world of giving and receiving. This is how the dream begins. Not with a roar, not with a sudden explosion of life, but with a quiet, symbiotic whisper. One polyp building its tiny cup. It settles onto a hard, submerged surface, a rock, a sunken shell, the edge of an ancient reef. It anchors itself. It begins to feed, its tentacles gently capturing microscopic morsels from the water. And then it does what all life, in its patience, knows how to do. It grows. It replicates itself. Slowly, almost imperceptibly, it begins to clone. It creates an exact copy of itself, a second polyp budding off from its own body. This new polyp builds its own stony cup right beside the first. Then a third, a fourth, a colony is born. They become a community of connected individuals, all sharing the same genetic code, all working in silent unison. Their collective limestone skeletons fuse together, forming a stony base that grows year after year, decade after decade. What was once a single, solitary dreamer becomes a family becomes a township becomes a city of stone, rising slowly from the seafloor. The great branching arms of staghorn coral, the massive brain-like boulders of lobe coral, the delicate plate-like tears of leaf coral, all of them are the work of countless billions of these tiny, connected polyps, all dreaming the same collective dream. And it all started with one. A single, soft-bodied polyp, no bigger than a grain of rice, deciding to build itself a tiny cup of stone and open its arms to the sun. It is a gentle reminder that the grandest, most vibrant structures in our world often have the simplest, most peaceful of beginnings. A dream of community, of partnership, of slow, patient growth. A dream that continues even now in the warm, shallow seas, one polyp at a time. From the dream of one emerges the work of billions. A single polyp is a poet of the minute, a weaver of a single perfect syllable. But when these syllables are spoken together over centuries, they form an epic poem written in stone. The coral reef is that poem, and its authors are a silent, countless multitude. They are the architects of the reef, building not with haste or with noise, but with the slow, inexorable patience of life itself. Imagine that first polyp, secure in its limestone cup. It has fed, it has grown, and it has felt the gentle, internal nudge to replicate. It begins to bud, a process as natural and unhurried as a leaf unfurling. A small bump forms on its side, a tiny outgrowth of its own tissue. This bud grows, developing its own mouth, its own crown of tentacles, and it begins the very same quiet work of its parent. It draws minerals from the sea, secreting its own limestone cup, right next to the first. They are now 2, then 4, then 8. A single polyp becomes a colony, a community of clones, all genetically identical, all working in perfect, mindless harmony. This is the foundational act of reef building. It is not a coordinated effort of thought, but a simple biological imperative to grow. Each polyp adds its own small contribution to the collective skeleton. As the colony expands, it takes on a shape, a form dictated by its genetic code. Some grow upward, reaching for the sun in delicate, branching antlers. This is the staghorn coral. Others grow outward, laying down layer upon layer of limestone to form massive, rounded boulders that can span meters across and be centuries old. This is the brain coral. Still others form delicate, overlapping plates, like a stack of stone saucers set out to dry in the blue gloom. Each shape is a different strategy for capturing light, for resisting currents, for surviving in the vast, liquid world. And so the architecture begins. A single colony becomes a building. 100 different colonies, each with its own unique shape and texture, become a cityscape. The branching corals create a sprawling underwater forest, its canopy offering shelter to tiny fish and crustaceans. The massive boulders become the foundational bedrock, the great hills and citadels of the reef. The plate corals create shaded overhangs and secret ledges, rooms within the city that never see the full light of day. But this is not a city built in a year, or even a century. The growth of a reef is measured in millimeters per year. A thriving staghorn coral colony might add a few precious centimeters to its branches in a good year. A massive porites boulder may grow less than a single centimeter. This is a time scale that defies human perception. It is geology happening in real time, but at a pace so slow it feels like stillness. A reef we see today is the accumulated work of thousands of years. It is a living heirloom, a structure that has been under continuous patient construction since long before our oldest civilizations were conceived. The work of these tiny architects is not a solitary one. They are the master builders, but they are not the only laborers. As the limestone structures rise and complexify, they create a surface, a substrate, a blank canvas for other life to settle upon. Coralline algae, a hard, pinkish crust, begins to grow over the dead spaces between coral colonies. This algae acts as a living mortar, cementing the rubble and binding the entire structure together, making it more resilient to the ocean's constant push and pull. The reef, then, is a collaborative masterpiece. It is built by the polyps, fortified by the algae, and inhabited by a universe of creatures that, in their own ways, contribute to its stability. The parrotfish, with its beak-like teeth, scrapes at the coral to feed on algae, and in doing so, it grinds up the limestone, creating the fine white sand that settles in the lagoons. The sediment itself, the very bed of the seafloor around the reef, is a product of the reef's own slow decomposition. To float over a coral reef is to hover above a living history book. Your shadow falls upon structures that were ancient when the first pyramids were raised. You are looking at the work of generations of polyps so vast in number, it is beyond counting. Each one a tiny, soft-bodied mason laying down a single, minuscule brick in a cathedral that took 5,000 years to build. There is no foreman, no blueprint, no grand design. There is only a simple, elegant rule: grow, replicate, and build. The breathtaking complexity, the stunning beauty, is an emergent property. It is what happens when a simple, patient process is given the gift of deep. The architects of the reef ask for no recognition. They do not rush. They do not strive. They simply are, and in their being they build. They transform the fluid, shifting nature of the sea into a solid, enduring landscape of life. They are a testament to the power of the small, the slow, and the collective. A reminder that the most enduring monuments are not built by force, but by persistence. Beneath the warm, tropical sun, in the clear, shallow waters where the light dances on the sandy floor, the coral reef thrives in a riot of color. But this vibrancy is a shared dream. The brilliant yellows, the rich browns, the deep greens that paint the underwater city are not the coral's own. They are the colors of 1,000,000 tiny suns burning softly within. This is the story of the sun farmers, the hidden inhabitants who turn light into life, and in doing so, make the reef possible. Inside the transparent tissues of every living coral polyp reside millions of microscopic algae. Their name, zooxanthellae, is a gentle, flowing word that seems to capture their essence, a whisper of life from another kingdom. They are not invaders, nor are they merely passengers. They are partners. They are the solar panels of the polyp, the internal gardeners who have turned the animal's body into a greenhouse bathed in blue light. The relationship is one of the most elegant and efficient in all of nature. The zooxanthellae are photosynthetic. They are tiny plants adrift in an animal world. They take the sunlight that penetrates the water, and through the quiet, ancient alchemy of photosynthesis, they transform it into energy, too. They use this energy to create sugars, lipids, and other nutrients. But here is the miracle of the partnership. They do not hoard this bounty. They share it. They release a significant portion of the food they produce directly into the tissues of the polyp. It is a constant, silent offering. In return, the polyp provides everything the algae needs to conduct its peaceful work. It offers a secure apartment, safe from the endless drift of the open ocean. It provides a front-row seat to the sun, nestled in the polyp's clear tissues, positioned perfectly to catch the day's rays. The polyp also supplies a steady, reliable source of carbon dioxide, the very breath of the polyp's own metabolism, which is the essential ingredient for the algae's photosynthesis. It is a perfect closed-loop economy. Waste becomes food, and light becomes life. This partnership is the reason coral reefs are found only in shallow, sunlit waters. They are not just communities in the ocean, they are communities built by the sun. The energy provided by the zooxanthellae is so vast, so efficient, that it supercharges the polyp's ability to build its limestone skeleton. With this abundant internal source of food, the polyp can dedicate its energy to the slow, deliberate work of calcification. It can draw minerals from the sea and weave them into stone at a rate that would be impossible otherwise. The sun farmers. Within are the engine of the entire construction project. The colors they paint are a reflection of their presence. Different species of coral host different types of zooxanthellae, each with its own unique blend of photosynthetic pigments, which gives each coral colony its distinctive hue. A deep brown, coral is packed with zooxanthellae eagerly harvesting the light. A vibrant blue or green coral may have special fluorescent pigments that act as a kind of sunscreen, protecting the delicate algae within from too much of a good thing. The reef's palette is not merely decorative, it is a visual map of the health and activity of its internal sun farmers. This intimate embrace is the source of the reef's great strength, but also its profound vulnerability. When the water grows too warm or when the sun's rays become too harsh, the delicate balance of this partnership shatters. Stressed, the polyp may expel its tiny algal partners, breaking the bond that sustains it. This is the phenomenon known as coral bleaching. When the zooxanthellae are gone, the color vanishes and the coral appears a stark, ghostly white. But more importantly, the food factory is shut down. The polyp is still alive, but it is starving, left with only its stony cup and the faint hope that conditions will improve, allowing its partners to return. To understand this symbiosis is to understand the very soul of the reef. It is not a collection of individual animals, but a fusion of kingdoms. It is a world where animal and plant have merged their lives so completely that one cannot truly exist without the other. The polyp provides the structure, the ambition, the architecture of stone. The zooxanthellae provide the fuel, the color, the very breath of life drawn from the sun. As you drift over a reef, watching the dappled light play across its contours, remember that you are not just looking at coral. You are looking at a vast, submerged farmland. You are witnessing a harvest of light happening in slow motion inside the bodies of billions of tiny creatures. It is a peaceful, perpetual transaction, a gentle bargain struck between animal and plant, a partnership that has built one of the most magnificent wonders of our world, all powered by the quiet, persistent work of the sun farmers within. As the sun begins its slow descent towards the horizon, its golden light filtering through the water column becomes softer, longer, and more diffuse. The bright electric blues of the day give way to the deep, mysterious indigos of evening. On the coral reef, this is not an ending, but a transition, a changing of the guard. The great city does not sleep. It simply shifts its rhythm, trading the bustling energy of the day for the patient, deliberate pulse of the night. The day shift is a world of color and swift movement. The herbivorous fish, the parrotfish, the surgeonfish, the vibrant tangs have spent their hours in the sunlit pastures, grazing diligently on the algae that coat the coral. Their constant nibbling work is the maintenance crew of the reef, keeping the structures clean and clear for the coral polyps to bask in the light they need. Predators like the reef shark or the trevally patrol, the blue voids, their swift, silent movements, a constant, quiet pressure that shapes the behavior of every smaller creature. It is a time of photosynthesis and visibility, of brilliant displays and swift escape. But as the last rays of sunlight withdraw, a profound transformation begins. The day shift workers retreat. The schools of grazing fish melt away into the gloom, finding crevices in which to huddle, their colors fading to dull, camouflaged hues as they rest. The great predators, their hunting advantage of sight diminished, often retreat to the open water or to known cleaning stations. A deep, blue silence seems to fall, broken only by the constant, soft sigh of the waves far above. This is the moment the night shift stirs. The city, which by day was built of stone and light, is now rebuilt in feeling and vibration. Creatures that would be vulnerable in the glaring sun now emerge, their world defined not by color, but by touch, by scent, and by the subtle electrical fields they perceive in the water. The most dramatic change is in the coral polyps themselves. By day, many of them retract into their stony cups, minimizing their soft flesh to avoid the attention of grazers. But as darkness falls, they feel a new safety. Across the reef, a silent, slow-motion bloom occurs. Millions upon millions of polyps extend their delicate tentacles, unfurling them into the water like a field of flowers, opening to a night-blooming moon. The reef surface, which by day was a hard, stony landscape, becomes a vast, living carpet of gently waving fronds. It is a breathtakingly beautiful and serene sight, the city revealing its true, soft heart under the cover of darkness. These extended tentacles are now hunting. Each one is armed with microscopic stinging cells called nematocysts. They are waiting. The night shift in the planktonic world is also beginning, and trillions of tiny animals, zooplankton, rise from the depths to feed under the safety of darkness. As these invisible drifts of life sweep over the reef, the coral polyps feast. Their tentacles sting and capture the tiny morsels, drawing them back to their waiting mouths. This is their supplemental nutrition, the direct harvest from the sea, a different meal from the sugars provided by their internal sun farmers. Other hunters join the quiet fray. The moray eel, a serpent of the shadows, now slides from its lair. Its poor eyesight is no handicap in the dark. It navigates and hunts by scent, weaving through the coral canyons with a fluid, sinuous grace. Lobsters and crabs, hidden in their crevices by day, now venture out on jointed legs, their antennae twitching, scavenging for any scraps the night might offer. The octopus, the ghost of the reef, is truly in its element. A master of shape, texture, and color, even in the dark, it flows across the seafloor, its body a liquid intelligence, exploring every hole, feeling for the telltale shape of a sleeping crab or a clam. Its movement is a silent ballet, a perfect expression of the night's slow, patient predation. This is not a shift of frantic activity, but one of profound purpose. The pace is different. Everything moves with a deliberate, cautious slowness. There are no frantic chases, only the slow, assured stalk. The sounds of the reef change too. The daytime chorus of clicks and pops may soften, replaced by the rustle of a crab over rock, the gentle whoosh of a hunting fish, the almost imperceptible scrape of a sea urchin moving across the substrate. The reef at night is a lesson in sensory adaptation. It is a world where the primary language is not sight, but touch and chemistry. It is a city that has traded its vibrant visual identity for a tactile, intimate one. The same structures that provided shelter from the sun now provide ambush points in the dark. The same currents that brought nutrients by day now deliver a nightly rain of plankton. As the first hints of dawn begin to bleach the eastern sky, the process reverses. The polyps, their nightly feeding complete, slowly, gracefully, retract their tentacles back into the safety of their skeletons. The nocturnal hunters retreat to their hidden homes. The day shift workers, their colors slowly intensifying with the growing light, begin to emerge and stretch their fins. The city that never sleeps has completed another cycle. It is a place of two hearts, two rhythms beating in the same chest. One is the bright, fast beat of the sun, and the other is the deep, slow, patient pulse of the moon. And in the gentle, endless turning from one to the other, the reef finds its balance, its continuity, and its timeless, serene life. While the stony corals are the architects building the city's foundations and skyline, there are other inhabitants who are the dancers. They are the living tapestries, the soft sculptures that adorn the reef, lending it a grace and fluidity that stone alone could never achieve. These are the soft corals, the sea fans, and the sea whips. They do not build with limestone, but with a flexible, horn-like substance called gorgonin, and their lives are not centered on the sun, but on the ceaseless, rhythmic pulse of the ocean's breath, the current. To see a sea fan for the first time is to witness a piece of the reef dreaming of being a tree. They rise from the seafloor in great, elegant, branching plates, often oriented perpendicular to the prevailing current. They are not rigid, but supple, bending and swaying with the water's flow like a feather in a gentle breeze. Their colors are often more subtle than their stony cousins, soft lavenders, dusty roses, buttery yellows, and muted oranges. They are the pastel watercolors to the stony coral's vibrant oils. These beautiful structures are, in fact, colonies of thousands of tiny polyps, much like the stony corals. But these polyps have a different purpose and a different rhythm. They are master filter feeders. Their entire existence is a meditation on waiting and receiving. Each sea fan, each sea whip, is a perfectly designed net stretched to the sea to harvest its invisible bounty. The current is their sustenance, their river of life. It carries a constant drifting snow of microscopic particles, plankton, detritus, and organic matter, the dust of life suspended in the blue. As this river flows through the reef, it passes through the intricate, lattice-like branches of the sea fan. And here, the thousands of tiny polyps spring into their quiet, rhythmic action. Each polyp is a miniature, 8-tentacled flower. When the current is right, they collectively extend their tentacles into the flow. The scene is one of the most hypnotic and peaceful on the reef. The entire colony seems to bloom, becoming covered in a fine, furry coat of gently pulsing white or yellow dots. Each tentacle is studded with tiny, sticky hairs that snare the passing particles from the water. The pulse is slow, a languid retraction to bring the captured food to the mouth, followed by a patient re-extension to begin the process again. It is not a frantic grab, but a serene, continuous harvest. They do not chase. They do not hunt. They simply stand in their fixed and beautiful poses and allow the world to come to them. Their dance is not one of pursuit, but of presence. The sea whip, a single, slender rod that can grow several feet tall, sways with a particularly graceful undulation, its polyps blooming along one side like a living feathered plume. It is a metronome, keeping time with the ocean's heartbeat. This existence requires a profound trust in the environment. They are utterly dependent on the currents. A day without flow is a day without food. Their beautiful, planar shapes are a direct evolutionary response to this need, maximizing their surface area to intercept the greatest possible volume of water. They are living proof that sometimes the most effective strategy is not to strive, but to align oneself perfectly with the forces of nature, to become a conduit for its abundance. They also play a vital, quiet role in the reef's community. Their complex branching structures provide a forest-like habitat for an entire micro-community of creatures. Tiny, exquisitely camouflaged crabs and shrimp cling to their branches, their bodies often mimicking the color and texture of the coral perfectly. Brittle stars wrap their slender arms around the gorgonin, holding on against the flow. Small, delicate fish like the pygmy seahorse, a creature of such subtlety it seems almost imaginary, spends its entire life anchored to a single sea fan, its body adorned with matching, fleshy protrusions. To watch a forest of sea fans in a steady current is to witness a form of aquatic yoga. It is a lesson in flexibility and resilience. They do not resist the current, they embrace it. They yield to its power, using that very energy to sustain their lives. They bend so they do not break. In a storm, the rigid, stony corals might be shattered by the force of the waves, but the soft corals will simply bow deeply, folding in on themselves, and when the storm has passed, They will slowly, gracefully unfold and resume their dance. There is a deep philosophical serenity in their way of life. They remind us that not all nourishment requires active pursuit, that there is wisdom in stillness, in positioning oneself correctly, and in receiving what the world offers. They are the reef's yogis, its meditative souls. They add a dimension of softness and flow to the hardscape of the city, a constant visual reminder that the ocean is a fluid, moving entity. So when you find your mind racing, think of the sea fan. Imagine yourself rooted yet flexible. Picture the nourishing currents of life flowing past, and trust that by simply being present, by extending your own gentle awareness into the flow, you too can harvest what you need. They stand in the eternal blue, dancing their slow, patient dance, filtering not just food from the water, but a deep and abiding sense of peace for any soul lucky enough to watch them breathe. In the sun-dappled world of the shallow reef, the primary source of energy is clear. It is the sun, captured by the internal farmers, the zooxanthellae, fueling the great construction project below. But this is only part of the story. From the vast, dark and seemingly empty waters above, another kind of sustenance descends. A gentle, continuous, silent rain. This is marine snow, and it is the manna from heaven that feeds the deep places and supplements the entire reef. Marine snow is not one single thing, but a beautiful, poetic term for a constant shower of organic debris. Picture the flurry of snow outside a window on a calm winter's evening. Each flake is unique, a delicate aggregate. In the ocean, each flake of marine snow is a tiny, drifting world. It is a composite of dead plankton and microscopic algae, the tiny carcasses of miniature creatures, flecks of waste from larger animals, discarded mucus-feeding nets and dust from the atmosphere. All of it glued together by a natural, sticky bacterial glue, forming fragile, languidly sinking flakes. This is the gentle rain that feeds the reef. It falls 24 hours a day, 365 days a year, in a slow, endless descent from the sunlit surface waters to the abyssal plains far below. Its pace is not one of a crashing waterfall, but of a feather's fall. A single flake may take weeks to sink from the surface to the deep seafloor, drifting and meandering in the subtle currents. For the creatures of the reef, this snow is a vital source of nutrients from the wider world. The surface waters where light penetrates are where most primary production occurs, where phytoplankton, the single-celled plants of the ocean, bloom. When these tiny lives end, or are consumed and excreted, they begin their long journey downward. This transports energy and nutrients, carbon, nitrogen, phosphorus, from the productive surface to the communities below, like the reef, which would otherwise be isolated in a nutrient-poor desert. The reef has learned to harvest this rain. As the marine snow drifts through the coral city, it is intercepted. The many filter feeders who live their lives in patient stillness are perfectly adapted to capture it. The soft corals and sea fans with their gentle, pulsing polyps are not just catching live plankton, but also these nutritious sinking flakes. Their sticky tentacles are just as effective at snaring this detritus from the current. But it is not only the obvious filter feeders who partake. Many of the stony coral polyps, especially at night, will extend their tentacles to catch this organic snowfall. It is a supplement to the sugars provided by their zooxanthellae, a direct intake of proteins and other nutrients from the open ocean. For them, it is like a gentle, nightly delivery of groceries. Other creatures are more dedicated to this bounty. Feather stars and basket stars, relatives of the starfish that look like living, intricate ferns, will climb to the highest points on the reef, the tips of sea whips, the edges of coral ledges, and unfurl their many-branched arms into the current. They are positioning themselves perfectly to act as living nets, straining the snow from the water as it drifts past. Brittle stars hidden deep within the crevices of the reef will extend one or two slender arms out into the open, waving them slowly to capture the falling flakes, a quiet and minimalistic way of feeding. The very sediment of the reef is, in part, composed of this ancient rain. The accumulated, uneaten remains of marine snow, along with the fine sediments produced by parrotfish and other eroders, settle into the sandy patches and lagoons. Here, a whole other ecosystem thrives. Sea cucumbers, the humble vacuum cleaners of the sea, move over the sand with a painstaking slowness, ingesting this sediment, digesting the organic goodness from the marine snow and other detritus, and excreting clean, filtered sand. Their work is the final step in processing this gift from above, recycling it one last time for the benefit of the reef. This constant, gentle precipitation is a humbling reminder of the interconnectedness of the ocean. A diatom that lived and died in a sunlit surface, bloom 100 miles away, may, in its final, aggregated form, become a meal for a coral polyp in a quiet lagoon. The waste from a passing pod of dolphins far out at sea can sink and eventually contribute to the growth of a sea fan. The entire ocean is linked by this vertical bridge, this slow-motion snowfall that connects the surface to the depths, the open ocean to the coastal reef. To think of marine snow is to understand that no part of the ocean is truly barren. Even in the midnight zones where light has never reached, this rain continues to fall, sustaining strange and wonderful life in the perpetual dark. It is the great recycler, the ultimate connector. So, the next time you float over a reef, watching the sunbeams cut through the blue, look not just at the light, but at the spaces in between. In the water column, you will see it, a million tiny glittering particles caught in the light, drifting slowly, inexorably downward. It is a silent storm, a blizzard of life, a peaceful, endless rain that feeds the world below, ensuring that even in the stillness, nourishment falls like a gentle blessing from the world above. On the bustling avenues of the coral city, there are no spoken words. No audible calls echo through the canyons, no shouts of warning or songs of courtship, at least none that human ears can easily discern. Yet the reef is far from silent. It is filled with a constant flowing dialogue, a silent symphony of information exchanged through movement, color, and light. The fish of the reef are engaged in a continuous, hypnotic ballet of communication, a language written not in sound, but in the visual poetry of their very beings. To understand this language, we must learn to see the reef not as a collection of individuals, but as a living tapestry of signals. A flick of a fin, a flash of color, a specific posture, each is a word. A sequence of these movements is a sentence. The primary dialects of this silent tongue are color, pattern, and motion. Color is the most obvious vocabulary. The breathtaking palette of a reef fish is not merely for our admiration. It is its uniform, its name tag, and its mood ring, all in one. The vibrant electric blue of a damselfish patrolling its tiny algal farm is a bold statement of territory, a clear keep away sign to any intruder. The complex painterly patterns of a mandarin fish, a labyrinth of swirling orange and blue, serve as disruptive camouflage, breaking up its outline amongst the textured coral, but may also play a role in recognizing mates in the dim twilight. These colors can change in an instant. Many fish possess specialized cells in their skin called chromatophores, which can expand or contract to alter their appearance. A flounder settling onto the sand will seem to melt into the background, its skin mimicking the pattern and color of the grains beneath it in a matter of seconds. A conversation with the environment itself, a whispered statement of "I am not here." A male wrasser, during courtship, might suddenly intensify his colors, flashing brilliant hues of emerald and sapphire in a silent, urgent serenade to a passing female. But color is a static billboard. Motion is the dynamic, fluid grammar that gives the language its context. The way a fish moves speaks volumes. Consider the steady, rhythmic, almost metronomic paddling of a butterfly fish as it glides over the reef. This is a calm, neutral statement. It is the equivalent of a peaceful stroll through the park. Now contrast this with the sudden, frantic jittering of a small goby. A rapid, vibrating motion, often accompanied by a specific head flick, is a universal sign of alarm and submission. It is a fish saying, "I see you, you are bigger than me, please do not eat me." This submissive jitter often disarms the aggression of a larger territorial fish. The flick of a fin can be a punctuation mark. A sharp, deliberate flare of the pectoral fins in an angelfish can be a warning to a competitor. The way a fish orients its body, broadside to another fish, is often a display of size and aggression, a visual boast. The mesmerizing, wave-like undulation of the fins on a lionfish, while partly for propulsion, is also a continuous display of its venomous spines, a silent, floating warning that says, "I am beautiful and I am dangerous. Do not touch." Perhaps the most hypnotic conversation is the synchronized movement of a school. A school of silversides turning as one entity is a breathtaking sight. There is no leader barking orders. The communication is instantaneous, a subtle, hydrodynamic and visual connection between every individual. A flick of a tail in one fish is perceived and mirrored by its neighbors in a wave that passes through the school faster than thought. This is the language of collective consciousness, a silent agreement that translates into a fluid, living cloud, a defense mechanism that confuses predators. It is a conversation where the entire group speaks with a single, flowing voice. Even the absence of motion is a statement. The freeze response, when a fish suddenly stops all movement and hovers, hoping to become invisible, is a powerful, fear-laden word in this visual dictionary. It is a desperate held breath in the face of danger. These quiet conversations create a complex, layered society. A surgeonfish grazing on algae is constantly signaling its non-threatening intent through its steady, feeding-focused movements. A pair of clownfish weaving through the stinging tentacles of their host anemone use gentle touches and specific postures to reaffirm their bond and maintain their immunity to the sting. The entire reef is a stage for this endless, non-verbal performance. To float weightlessly above this scene is to be a silent observer at a grand, diplomatic ball. You are witnessing a world of nuanced social contracts, of territorial disputes, of courtship rituals, and of survival strategies, all conducted in a serene, visual silence. There is no noise, only the gentle swish of water displaced by a tail, the soft crackle of the reef itself. It is a deeply calming spectacle. The human brain, so often overwhelmed by the cacophony of spoken language, can find a strange peace in observing this elegant, wordless communication. It is a reminder that understanding does not always require sound. That meaning can be conveyed in a glance, a posture, a fleeting color. The reef fish, in their silent, graceful ballet, are speaking a universal language of life, one that is felt rather than heard, a continuous, hypnotic, and profoundly peaceful conversation in the blue. On the stage of the reef, amidst the bustling crowds and silent conversations, there exists one of nature's most perfect and graceful partnerships. It is a living duet, a slow, endless waltz performed by two seemingly mismatched partners, the sedentary, flower-like anemone and the vibrant, darting clownfish. Their relationship is a masterpiece of coevolution, a dance of trust, protection, and mutual benefit that has become an iconic symbol of the reef's interconnected serenity. The sea anemone is, in itself, a creature of paradoxical beauty. It is not a plant, but a predatory animal, a cousin of the jellyfish and the coral polyp. Its body is a soft, muscular column anchored to the rock. At its top is an oral disc surrounded by a crown of tentacles. These tentacles are armed with microscopic, harpoon-like stinging cells called nematocysts, capable of firing a paralyzing toxin into any small creature unfortunate enough to brush against them. To most fish, an anemone is a deadly blossom, a beautiful trap to be avoided at all costs, and yet, for the clownfish, it is home. The clownfish, with its bold bands of orange and white, moves through this forest of stinging tentacles with an impossible grace. It approaches not with caution, but with the familiarity of a resident returning to its apartment. It will brush its sides against the tentacles, nestle deep within them to rest, and even deposit its eggs on the rock beneath the anemone's disc. Guarded by the very stings that should mean its end, this immunity is not innate, it is earned. A clownfish is born without its protective slime coat. To gain entry into its host, it must perform a slow and careful courtship dance. The young fish will gingerly approach the anemone, touching a tentacle and then darting away, allowing its body to receive a small, controlled dose of the sting. It does this again and again over hours or even days, gradually acclimating itself, and scientists believe coating itself in the anemone's own mucus, a chemical cloak that makes it smell and taste like a part of the anemone itself, rendering it invisible to the stinging cells. This is the first step of the waltz. A slow, tentative approach, a building of trust, a merging of identities until the two become one. Once the partnership is sealed, the dance of daily life begins, a dance with benefits for both. For the clownfish, the advantages are clear. It gains a fortress. Protected within the stinging tentacles, it is safe from the vast majority of predators. It has a guaranteed home, a place to sleep, to mate, and to raise its young in one of the safest nurseries on the reef. But what does the anemone receive in return? The payment comes in many forms. The clownfish, with its bright colors and active movements, acts as a lure, attracting larger fish closer to the anemone's tentacles, potentially increasing its chances of a meal. More importantly, the clownfish is a diligent housekeeper. It will voraciously defend its home from anemone-eating predators, such as certain butterfly fish, fearlessly chasing away much larger intruders. It also ventilates the anemone, its constant finning and swimming helping to circulate oxygen-rich water around its host's tissues, and it will often eat the anemone's dead tentacles or leftover food scraps. Keeping the immediate area clean, their communication is a subtle physical language. The clownfish will often gently nudge and nibble at the anemone's tentacles, which may stimulate the anemone to open its oral disc more fully. The anemone, in turn, responds to the movements of its resident, its own body subtly shifting to accommodate the fish. They are in constant, quiet contact, a tactile conversation that has been perfected over millennia. To watch a clownfish family woven into the flowing arms of a magnificent anemone is to witness a perfect, self-contained world. The fish dart and play, their bright orange forms a stunning contrast to the often muted greens, browns, or brilliant blues of their host. They weave through the tentacles in a fluid, living tapestry. The anemone, in its stillness, provides the stage and the security, while the clownfish provide the movement and the vitality. It is a partnership of stillness and motion, of patient waiting and energetic action, perfectly balanced. This endless waltz is a profound lesson in symbiosis. It shows that the most secure foundations are often built on trust and mutual benefit. It demonstrates that the fiercest defenses can become the safest havens. And it reminds us that even the most different of beings, one rooted, stinging, and patient, the other free-swimming, vibrant, and active, can find a way to coexist in a harmonious, lifelong embrace. So as you observe this tranquil duet, let it be a meditation on partnership. The anemone and the clownfish do not fight their natures. They have learned to weave them together into something stronger and more beautiful. They dance their quiet waltz day in and day out, a slow, spinning testament to the peace that can be found in a perfect, mutual understanding. Amid the fluid dances and silent conversations of the reef, there is a sound that grounds the entire symphony. It is not a gentle swish or a soft pop, but a low, rhythmic crunch. A steady, grinding noise like pebbles being slowly turned in a tumbler. This is the sound of the reef's patient gardener, the parrotfish, at work. And in this seemingly destructive act lies one of the most vital and transformative processes in the entire coral city. The parrotfish is a creature that seems assembled from a dream. Its body is often a riot of tropical color, electric blues, sunset oranges, deep purples, and vibrant greens, swirled together as if by an artist's brush. But its most defining feature is its face. Its teeth are not separate. They are fused together into a strong, beak-like structure, a dental plate that gives the fish its name. This beak is a powerful tool evolved for one primary purpose: to eat coral. To see a parrotfish for the first time, methodically scraping its beak across the surface of a coral head might seem an act of pure vandalism. It appears to be destroying the very architecture it calls home. But this is a profound misunderstanding. The parrotfish is not a destroyer. It is a pruner, a recycler, and ultimately the creator of the reef's most iconic feature: the sand. The process is one of elegant, if noisy, efficiency. The parrotfish uses its powerful beak to bite off small chunks of the coral's limestone skeleton. Its target is not the stone itself, but the thin, living layer of polyps and the nutritious algae that coat the rock. To access this food, it must take the stone with it. Inside its mouth, just behind the beak, lies its true marvel of evolution, a set of pharyngeal teeth. These are secondary teeth located in its throat that are hard, flat, and arranged in a grinding mill. As the chunk of coral is swallowed, it passes into this pharyngeal mill. The fish's powerful muscles work to grind the rock against these teeth, pulverizing the stony skeleton and crushing the polyps and algae within. It separates the nourishing organic matter from the indigestible powdered limestone. What happens next is the magic. The organic material is digested, fueling the parrotfish's vibrant life. The finely ground, white calcium carbonate, the pulverized coral skeleton, is, quite simply, excreted. A single parrotfish can produce hundreds of pounds of this sand each year. After a feeding session, you can often see a fine, white cloud puffing out from behind the fish, a gentle snowstorm of future beaches settling onto the reef. This constant, diligent gardening is essential for the health of the reef. By scraping the substrate clean, the parrotfish prevents fast-growing weedy algae from smothering the slower-growing corals. It prunes the reef, clearing space for new coral larvae to settle and grow, much like a terrestrial gardener weeding a flower bed to allow the desired plants to thrive. Without these colorful gardeners, the reef would become an overgrown, algal-dominated landscape, and the delicate balance of the ecosystem would falter. The sand they produce is not a waste product. It is a fundamental building block of the tropical world. The brilliant white sand beaches of countless tropical islands, the very picture of paradise, are largely composed of parrotfish poop. The sand in the lagoons, the material that fills the spaces between coral heads, the very substrate that new corals need to anchor onto, all of it is continuously replenished by the patient, grinding work of the parrotfish. They are the ultimate alchemists, transforming the hard, complex structures of the reef into the soft, simple grains of the shore. Their life is a slow, methodical routine. They drift from one coral head to the next, their powerful tails providing steady propulsion, their beak leaving behind a distinctive, scraped clean patch on the coral. Some species are solitary. Others move in small grazing herds. At night they seek shelter in the reef's crevices, and some even secrete a protective, transparent cocoon of mucus around their bodies, a sleeping bag that masks their scent from nocturnal predators like moray eels. To watch a parrotfish is to witness the reef's great cycle of life and death made visible. It consumes the old to make way for the new. It takes the solid and makes it fluid. It is a reminder that destruction and creation are two sides of the same coin, and that even the most mundane of processes, eating and digestion, can, over time, create something of breathtaking beauty. So, the next time you find yourself sinking your toes into the warm, powder-soft sand of a tropical beach, pause for a moment. Look out at the blue line of the reef on the horizon. That sand was not always so. It was once part of a mighty living fortress, and it was transformed patiently, crunch by gentle crunch, by the reef's colourful dedicated gardener, the parrotfish, a living reminder that from endings come beautiful beginnings, and that paradise itself is built on a foundation of quiet, persistent, and purposeful work. Beyond the dramatic drop-offs and the bustling vertical walls of the outer reef lies another world, one that basks in the full, unfiltered embrace of the sun. This is the Reef Flat, a vast, shallow plateau that stretches like a sun-drenched plain between the shore and the deep blue. Here, the water is often no deeper than your knees, a warm, liquid skin over a living mosaic. It is a world of intense light, gentle waves, and profound productivity, serving as the primary nursery and kindergarten for the entire reef. To wade into a reef flat is to step into a different rhythm. The frantic energy of the drop-off is replaced by a slower, more deliberate pace. The light here is brilliant, penetrating every corner, fueling a frenzy of photosynthesis. The substrate is a complex tapestry of life and structure, patches of hardy branching and encrusting corals, vast gardens of seagrass and fields of rolling sand, all interspersed with rubble and isolated coral bommies that rise like miniature mountains from the plain. This mosaic of habitats is what makes the reef flat so vital. It is the cradle of the reef. The very shallowness that makes it vulnerable to air exposure at low tide is what makes it a perfect nursery. Predators, larger and requiring deeper water to maneuver, are less common here. The complex, small-scale structure provides endless nooks and crannies for tiny creatures to hide. Look closely at a patch of seagrass, its green blades swaying in the surge like a terrestrial meadow in the wind. This is not merely a plant, it is a sanctuary. Within this underwater prairie, countless juvenile fish find refuge. Tiny snappers, no larger than a fingernail, dart between the blades. Minute groupers, already displaying the characteristic large mouth, hover just above the bottom, perfectly camouflaged against the sandy patches. The seagrass roots stabilize the sediment, and its blades provide a surface for sponges, tunicates, and bryozoans to grow, adding yet more complexity to the nursery. The isolated coral bommies are the cities of this plain. These stout, rounded coral heads have endured the full force of the sun and the occasional exposure to air, making them some of the hardiest colonies on the reef. They are microcosms of the larger reef ecosystem, hosting their own communities of damselfish, blennies, gobies, and crustaceans. A single bommy can be a universe unto itself, with residents that may spend their entire lives within a meter of their birthplace. The sand and rubble patches, which might seem barren at first glance, are teeming with secret life. This is the realm of the bottom dwellers, the architects of the subsurface. Watch the sand carefully and you will see it move. A small puff of sediment reveals the presence of a garden eel, a slender, wary fish that feeds on plankton while half buried, retracting into its burrow at the slightest shadow. The industrious goby shares its burrow with a blind pistol shrimp. The shrimp, the engineer, tirelessly maintains the home, while the goby, the watchman, stands guard at the entrance. Their partnership, a perfect, silent agreement. Life on the reef flat is lived in high definition. The brilliant light reveals colors with a clarity that is lost in the deeper blue. The intricate patterns on a flatworm crawling over a sponge, the iridescent sheen of a turban shell, the delicate, feathery arms of a brittle star tucked under a piece of rubble, all are rendered with stunning visibility. The constant low surge from the waves overhead creates a gentle, rocking motion, a rhythmic sway that lulls the entire landscape into a state of peaceful, sun-soaked productivity. This shallow world is also a place of dynamic change. With the tides, the environment transforms. At high tide, the reef flat is a submerged paradise, accessible to a wider array of visitors from the deeper reef. At low tide, it becomes a series of isolated pools, their inhabitants waiting patiently for the water's return, some even able to withstand brief periods out of water. This daily cycle of immersion and exposure has forged a community of incredibly resilient and adaptable life. The reef flat is the engine of the reef's renewal. The countless juveniles that grow to adulthood here will, in time, migrate to the deeper slopes, replenishing the populations of the main reef. The energy captured by the seagrass and the algae in the bright sun fuels the food web, from the tiny herbivores up to the occasional visiting predator. To spend time on the reef flat is to witness the reef at its most fundamental and hopeful. It is a landscape of beginnings. It lacks the grandeur of the abyss, but it overflows with the intimate details of new life. It is a sunlit nursery, a serene pasture, a mosaic of miniature worlds, each piece a vital thread in the larger tapestry of the reef. It is a place of gentle waves, bright light, and the quiet, persistent hum of life getting its start. A living testament to the fact that the future of the entire reef is born in these warm, shallow, and peaceful waters. From the sun-drenched, bustling nursery of the reef flat, the world falls away. It does not slope gently, but often plunges, a dramatic cliff of living stone that descends into the endless blue. This is the reef wall, the drop-off, the frontier between the known and the unknown. Here, the light begins to falter, softening from a brilliant gold to a deep, serene azure, and finally to a twilight indigo. This is a world of verticality, of silence, and of creatures adapted to the gentle embrace of the gloom. To drift along the face of the drop-off is to experience a profound sense of weightlessness and perspective. Above you, the sun is a distant, shimmering coin, its rays forming great wavering pillars of light that slowly fade into nothingness below. Behind you is the solid, complex tapestry of the reef wall, a vertical landscape of ledges, crevices, and overhangs, each one a dark doorway into a hidden world. Before you is the open blue, a vast, empty space that is anything but empty. The first thing you notice is the quiet. The constant soft crackle of the reef flat is muffled here. The light filtered through many meters of water loses its harshness, bathing everything in a soft, blue haze. Colors so vibrant in the shallows begin to bleed away. The reds and oranges are the first to be absorbed by the water, leaving a world painted in shades of blue, grey, and violet. A red sponge here appears as a deep, shadowy burgundy, almost black. A crinoid's vibrant yellow arms seem to glow with a soft, ethereal luminescence. Life on the wall is adapted to this half-light. The corals here are often different from their shallow water cousins. Encrusting forms dominate, spreading like a living skin over the rock, maximizing their surface area to capture every available photon. Gorgonians, sea fans, and sea whips thrive here, stretching their delicate tree-like forms into the current, their branches perfectly oriented to filter the nutrient-rich water that wells up from the depths. Their colors are often more muted, leaning into the purples, blues, and grays that blend with the twilight. This vertical world is a city of overhangs and hideaways. In the dark crevices and under the ledges, creatures that shun the light find their sanctuary. The long-spined sea urchin clusters in dark hollows, its needle-like spines a formidable defense. Lobsters and cryptic crabs peer out from the shadows, their antennae twitching, sensing the world from the safety of their rocky apartments. The wall provides a fortress, a place to retreat from the open water where the hunters patrol, and the hunters are here. The twilight zone is the realm of the ambush predator. The scorpionfish is a master of this art, lying perfectly still on a ledge, its body a mottled, algae-crusted lump, indistinguishable from the surrounding rock. It waits with infinite patience for an unsuspecting fish to wander within the lightning-fast strike of its gaping mouth. The moray eel, a serpent of the shadows, weaves through the crevices, its body a fluid muscle, hunting by scent in the dim light. But the true magic of the drop-off often lies in the blue void itself. To peer out into that endless open water is to look upon the pelagic realm, the great wilderness of the ocean. And here, visitors from the deep often appear. A school of jacks may materialize from the blue, their silver flanks flashing as they turn in unison, a shimmering, cohesive cloud investigating the wall before vanishing back into nothingness. A solitary eagle ray may glide past, its wing-like pectoral fins moving with a slow, graceful undulation, a silent ghost traversing the frontier. For the diver, suspended in the blue, the sensation is one of both insignificance and wonder. You are a visitor in a world that does not acknowledge you. The scale is immense, the silence profound. The slow, steady rhythm of your own breath becomes the loudest sound, a metronome marking time in this timeless space. It is a deeply meditative experience, a feeling of being suspended between two worlds, the sunlit reef above and the abyssal dark below. The drop-off is a gentle reminder of the ocean's vastness. It is the reef's quiet, mysterious edge, a place where light surrenders to shadow and the familiar gives way to the unknown. It is not a place of fear, but of serene awe. The blue haze softens all edges. The slow drift of the gorgonians in the current lulls the mind, and the occasional, graceful appearance of a pelagic traveler feels like a sacred gift. To experience the twilight zone of the drop-off is to understand that the reef is not just a two-dimensional landscape, but a profound vertical kingdom. It is a world of layers, of gradients, of life adapted to the gentle fade of light. It is a frontier of serene beauty, a blue-hazed dream at the edge of the world, inviting you to let go, to drift, and to simply be in the quiet, immense peace of the deep blue. The coral reef, in all its sprawling grandeur, is a landscape defined by its voids as much as its solids. For every towering coral head and great sea fan, there is a corresponding space, a dark fissure, a shadowed overhang, a labyrinthine network of tunnels and holes. To the casual observer, these are mere absences, the negative space in the reef's vibrant painting. But for a vast and secret community, these crevices are the entire world. They are the shy tenants of the hidden spaces, the introverts of the coral city who live their entire lives in the quiet, sheltered dark. To find them, one must learn a new way of seeing. It requires patience, stillness, and a gentle gaze that peers into the shadows without intrusion. The entrance to a crevice is a threshold. From the sunlit world outside, it appears as a simple gap in the rock. But step closer, let your eyes adjust, and a new universe slowly reveals itself. What seemed like an empty darkness is, in fact, a densely packed, vertical neighborhood. The architecture of a crevice is a masterpiece of microengineering. Sponges, in a wild variety of shapes and textures, line the walls. Some are smooth and vase-like, others are encrusting yellow pancakes, and still others are delicate, branching structures that look like bare winter trees. Tunicates, often called sea squirts, cling to the ceiling in brilliant clusters of orange. blue or white, each one a simple, sac-like creature, filtering the water that flows through its home. Feather duster worms crown their tube homes with magnificent spiraled plumes of gold and russet, retracting in a flash at the slightest hint of a shadow. This is the realm of the cryptic, the camouflaged, and the armored. Here, the flamboyant. Colors of the open reef are traded for disguises of supreme subtlety. The coral crab is a perfect example. Its shell is not a smooth, featureless surface, but a living landscape. It encourages sponges and algae to grow on its back, creating a perfect mobile camouflage. To look at it is to see not a crab, but a small walking piece of the reef. It will freeze if discovered, becoming utterly still, believing in its simple way that if it cannot see you, you cannot see it. Peer a little deeper into the gloom, and you might see the glint of two small bead-like eyes. A blenny or a goby, no longer than your finger, stares back from the safety of its tiny cave. These fish are the masters of their small domains. They claim a single hole, a specific shell, and from that fortress they watch the world go by. They will dart out to snatch a passing morsel of food, only to retreat just as quickly back into the safety of their home. Their lives are lived in inches, a testament to the fact that a vast territory is not a requirement for a full existence. In the deeper, darker recesses where the light barely reaches, other, stranger tenants reside. The brittle star, with its 5 slender, serpentine arms, weaves itself into a tangled ball within a crack, its arms just visible, sensing the water for the scent of food. The spiny lobster, a creature of the night, spends its days tucked deep within the reef's heart, its long whip-like antennae resting on the threshold of its lair, tasting the water for danger or opportunity. The life within the crevice is one of profound sensitivity. These creatures are attuned to the slightest vibration, the faintest change in light. A human hand reaching towards an entrance will cause a wave of retreat. The feather duster worms vanish in an instant. The crab presses itself flat. The blenny disappears into the darkness. The entire community holds its breath, waiting for the disturbance to pass. It is a world that values privacy and security above all else. Yet these hidden tenants are not isolated. They are deeply connected to the life of the open reef. The crevice acts as a natural filter, its countless sponge and tunicate residents constantly cleaning the water that flows through it. It is a sanctuary, a nursery for the young of many species who are too vulnerable to survive in the open. It is a larder for predators like the moray eel, who knows exactly which holes contain a plump crab or a sleeping fish. To spend time observing a single crevice is to practice a form of underwater meditation. It is to appreciate the small, the quiet, and the well-hidden. The great, sweeping vistas of the reef are magnificent, but the intimate, secret world of the crevice holds a different kind of magic. It is the magic of discovery, of being let in on a secret. It reminds us that life persists in the most unlikely places, that entire universes of complexity and beauty can exist in a space no larger than a loaf of bread. These hidden tenants ask for nothing but the peace of their shadows. They are the quiet souls of the reef, the recluses who have found everything they need in the cool, dark silence of a crack in the world. And in their quiet, hidden lives, they contribute to the reef's resilience, its biodiversity, and its enduring, mysterious charm. On the reef, sight often dominates. The dazzling colors, the graceful movements, the play of light, these are the elements that first capture our attention. But if you pause and truly listen, another dimension of this underwater world reveals itself. Close your eyes, and the reef is not a silent movie. It is a living orchestra performing a continuous, soothing symphony of sound. This is the soundscape of the reef, a composition of clicks, pops, crunches, and grunts, a gentle auditory tapestry that is as vital to the ecosystem as the corals themselves. The first thing you notice is the crackle, a constant, low-level static, like the sound of frying bacon heard from another room or distant rain falling on a still pond. This is the foundational layer of the reef symphony, its rhythm section. This pervasive sound is produced by countless tiny snapping shrimp hiding within their burrows and crevices. They possess an oversized claw that they can snap shut with astonishing speed. This action creates a cavitation bubble that, when it implodes, produces a loud click. The collective sound of millions of these shrimp, snapping day and night, creates this serene, crackling backdrop, the white noise of the coral city. But this is only the beginning. Listen more closely, and other instruments join the ensemble. The low, rhythmic crunching, as we have learned, is the parrotfish, the patient gardener, methodically grinding coral into sand. This is the percussion, a steady, metronomic beat that grounds the symphony in the physical work of consumption and creation. Then come the pops and grunts. Many fish are far from silent. They use their swim bladders, the internal organs that control their buoyancy, as musical instruments. By contracting special muscles, they can make their swim bladders resonate, producing a surprising array of sounds. Damselfish emit sharp, territorial pops. Different species of grunts, true to their name, produce a low guttural grunt, often when gathered in schools for the night, a chorus of sleepy conversations. The courting male midshipman fish is known for his long, droning hum, a vibrational love song that can last for hours. These are the woodwinds and the brass of the orchestra, adding melodic phrases and punctuations to the shrimp's constant static. This symphony is not merely a byproduct of life, it is a fundamental form of communication and navigation. In the blue haze, where sight is limited, sound travels far and fast. For the creatures of the reef, this soundscape is an auditory map, a social network, and a news broadcast, all in one. A larval fish, adrift in the vast ocean after hatching, must find its way home to a reef. Scientists believe it listens. The distant collective crackle and pop of a thriving reef acts as a sonic beacon, guiding the tiny fish through the featureless open water towards the safety and community of the coral. The reef, quite literally, sings its siren song, calling its children home. For the residents, the sounds convey immediate, vital information. The sudden cessation of the snapping shrimp chorus in one area can be a universal alarm, signaling the approach of a predator. The specific pattern of pops between damselfish can delineate territorial boundaries as clearly as a fence. The chorus of grunts from a resting school is a sound of safety in numbers. They are speaking to each other in a language of vibration, a continuous, flowing dialogue that we are only just beginning to decode. To float weightlessly in the water, eyes closed, and simply listen to this aquatic symphony is a deeply meditative experience. The crackle of the shrimp is a natural form of sonic therapy, a calming, predictable sound that can slow a racing heart and ease a busy mind. The occasional deeper crunch or distant pop adds texture without disrupting the serene foundation. It is nature's own ambient music, composed in real time by 1 billion unconscious musicians. This soundscape is a powerful indicator of the reef's health. A vibrant, noisy reef is a thriving reef, teeming with the life that produces these sounds. A silent reef, by contrast, is a reef in trouble, a ghost town where the orchestra has fallen silent. The symphony is a measure of biodiversity and abundance, a chorus of life that speaks volumes even when we are not there to see it. So, the next time you imagine a coral reef, do not picture it in silence. Picture it as a grand, living concert hall. The snapping shrimp are the string section, providing the endless, shimmering harmony. The parrotfish are the percussion, keeping a slow, steady beat. The grunting fish and popping damselfish are the woodwinds and brass, adding their unique voices to the mix. And all of it is conducted by the moon and the tides, a performance that has been playing for millions of years. It is a symphony not of drama but of existence, a lullaby of clicks and pops, a serene soundscape that is the true voice of the reef, a voice that is constantly whispering, humming and singing the gentle, enduring story of life. As the last rays of sunlight vanish and the reef is cloaked in the deep indigo of night, a different kind of magic begins to stir. The vibrant colors of the day have faded to monochrome silhouettes against the dark water. But if you were to shine a special blue light, or even wait for the moon to rise on a clear night, a secret world would ignite. The reef does not sleep. It begins to dream in brilliant electric color. This is the phenomenon of fluorescence, the reef's hidden palette, revealed only when the sun goes down. Fluorescence is a quiet sorcery of light and matter. By day, the corals are bathed in the full spectrum of sunlight. Certain pigments within the coral's tissues and within the bodies of some of its inhabitants have the ability to absorb the high-energy, invisible ultraviolet and blue light from the sun. They do not simply reflect this light, they transform it. They capture it, and a moment later they re-emit it as a lower-energy visible light of a specific glowing color. A dazzling green, a fiery orange, a deep blood red, a vibrant magenta. But this magical display is drowned out by the overwhelming power of the sun. It is only when the dominant white light fades that these hidden colors can finally be seen. It is as if the reef has been holding its breath all day, waiting for the curtain of darkness to fall so it can finally exhale its true, luminous self. To witness this is to step into a living dreamscape. With the aid of a gentle blue light, the reef is utterly transformed. A coral that by day was a simple, brownish lump now blazes with an intense, greenish-yellow fire, its polyps outlined in neon. A sea anemone, a muted olive in the sunlight, now pulses with a soft, pinkish-purple glow. A solitary sponge becomes a miniature crimson lighthouse in the dark. Even the tentacles of a jellyfish drifting through the black water can trail streamers of ethereal blue light. The effect is not of illumination, but of revelation. You are not shining a light on the reef. You are persuading the reef to reveal the light it has been holding within all along. Scientists are still unraveling the purpose of this beautiful display. The theories are as enchanting as the phenomenon itself. One prevailing idea is that it acts as a form of sunscreen. The corals live in an environment bathed in intense and sometimes harmful ultraviolet radiation. The fluorescent pigments may absorb this damaging UV light and re-emit it as safer, longer wavelength visible light, protecting the delicate zooxanthellae algae within. The coral is, in essence, creating its own protective, glowing shield. Another theory suggests it is a tool for optimizing light. In the deeper, bluer parts of the reef, where red light is scarce, some corals fluoresce in brilliant reds and oranges. It is possible they are converting the abundant blue light into the red light that their zooxanthellae need most efficiently for photosynthesis. They are, in a way, tuning the light of their environment to better feed their internal partners. For other creatures, the glow is a tool for communication and predation. The tentacles of some corals may fluoresce to lure in the tiny plankton they feed on, like a neon sign advertising a restaurant in the dark. A small, secretive fish, like the glowing tripplefin, has fluorescent markings around its eyes that may be used for signaling to its own kind in the dim light, a private conversation in a secret visual language. But beyond the science, the fluorescent reef exists in the realm of pure, tranquil wonder. To drift through this landscape at night is to feel as though you are floating through the stars. The glowing corals are constellations underfoot. The flicker of a fish's fin becomes a comet's trail. The gentle pulse of a jellyfish is a distant nebula. The usual sense of depth and perspective is lost, and you feel suspended in a vast, cosmic tapestry. The sound of your own breath is the only anchor, a soft, rhythmic reminder of your presence in this otherworldly scene. The usual hustle of the reef is gone, replaced by this silent, radiant exhibition. It is a deeply peaceful, almost spiritual experience. The reef is not showing off. It is simply being its true self, its inner light finally given a voice in the darkness. This fluorescent dream is a poignant reminder that there is often more than meets the eye, that beneath the surface of the everyday lies a hidden world of brilliance and magic, waiting for the right conditions to reveal itself. The reef by day is a monument to community and structure. By night, under the gentle persuasion of a blue light, it becomes a monument to inner light, to hidden potential, and to the quiet, beautiful dreams that come alive when the world is still. It is the reef's most serene and secret performance, a ballet of light and color played out in the hushed theater of the night. In the sun-drenched shallows of the reef, nestled among the corals and swaying seagrass, rests one of the ocean's most serene and majestic beings, the giant clam. It is a creature that embodies stillness, a living lesson in patience and the quiet art of basking. Its life is not one of pursuit or flight, but of rooted, deliberate existence, a slow journey from a microscopic wanderer to a gentle, filtering giant. The journey begins not in grandeur, but in anonymity. A giant clam starts its life as a tiny, free-swimming larva adrift in the vast planktonic soup. For a brief period, it is a traveler, carried by currents, a speck of potential in the blue, but soon it seeks its forever home. It settles onto a hard, sunlit patch of the reef, often in a sandy lagoon or a calm, shallow flat. It attaches itself with a tough, thread-like byssus, and here it will remain for the rest of its life, which can span a century or more. From this anchored point, the clam begins its slow, magnificent growth. Its two hinged shells, or valves, begin to secrete calcium carbonate, expanding year after year, millimeter by patient millimeter. Some species, like the true giant clam, can grow to over 4 feet in length and weigh hundreds of pounds. They become permanent fixtures of the landscape, their heavily ribbed shells resembling ancient, weathered stone, often covered in a patina of coralline algae, sponges, and tiny tube worms, a miniature ecosystem trusting in the clam's absolute stillness. But the true magic of the giant clam is not in its shell, but in the soft, living mantle that is often exposed within. This mantle is a breathtaking display of natural artistry. It is a canvas of iridescent blues, rich greens, shimmering golds, and deep purples, often dotted with hundreds of tiny jewel-like eye spots. These are not true eyes that form images, but light-sensitive organs that can detect changes in light and shadow, a simple awareness of the world passing above. This vibrant mantle is the clam's solar panel and its gills all in one. Like the corals, the giant clam has entered into a sacred partnership with photosynthetic algae, zooxanthella, which live in dense populations within its tissues. The clam positions its shell to gaps slightly open, orienting its mantle towards the sun. For hours each day, it simply basks. The zooxanthellae harvest the sunlight, producing sugars that nourish their host. The clam, in turn, provides them with a safe, sunlit home and a steady supply of nutrients from its own waste. This is its primary sustenance, a peaceful harvest of light. But the clam is also a master filter feeder. It draws water into its large body cavity through a siphon. Inside, its gills are covered in microscopic, hair-like cilia that create a current and trap tiny particles of plankton and organic matter, the marine snow that gently falls from above. The captured food is then transported to its mouth. It is a dual diet of sun and sea, a perfect self-sufficient existence that requires no movement other than the gentle opening and closing of its shell. Its rhythm is the rhythm of the sun and the tides. At dawn it may begin to open, its mantle slowly unfurling to greet the day. If a shadow falls over it, a passing ray, a swimming turtle, it may slowly, deliberately close its shell, not in panic, but in a measured response. Its closure is a deep, resonant sound, a low thump that is the audible expression of its immense strength. At night, it often closes more fully, resting in the private darkness of its own making. To observe a giant clam is to witness a profound state of being. It does not forage, it does not hunt, it does not flee. It is a testament to the idea that a rich, long life can be built on stillness and reception. It is the reef's great meditator, its Zen master. It reminds us that growth does not have to be frantic, that sustenance can be drawn from simply being present and open to the gifts of one's environment. The clam's very presence benefits the reef. Its filtering action helps clean the water. Its massive shell provides a solid substrate for new corals to settle upon and a shelter for small fish and crustaceans. It is a calm, benevolent landmark in the ever-shifting world of the reef. There is a deep, philosophical peace in its existence. In a world that often values speed and ambition, the giant clam presents an alternative, a life of profound patience. Its journey is not measured in miles traveled, but in layers of shell laid down. Its legacy is not in offspring it has chased, but in the calm, enduring space it has held for 100 years. So, when you encounter one of these gentle giants resting in its sunlit spot, take a moment. Watch the play of light on its iridescent mantle. See how it turns sunlight into substance and water into life. It is a living lesson in stillness, a reminder that sometimes the most profound journey is the one that goes nowhere at all, but simply sits and breathes and basks in the slow, beautiful passing of time. While the reef boasts its flamboyant dancers and brilliant architects, some of its most vital work is done by its humblest inhabitants. Moving with an almost geological slowness over the sandy patches and seagrass meadows is a creature that seems more like a lump of clay than a living animal. This is the sea cucumber, the reef's unassuming janitor, a gentle bulldozer whose quiet, diligent work is essential to the health of the entire ecosystem. The sea cucumber's appearance is one of profound simplicity. It is a leathery, elongated tube, often a muted brown, black, or olive green, sometimes adorned with soft, wart-like bumps. It looks like a forgotten sausage left on the seafloor. It has no face to speak of, no expressive eyes, no dramatic fins. At one end is a mouth, surrounded by a crown of feathery, sticky tentacles. At the other, is the other end. Its design is the epitome of function over form, but within this simple form lies a creature of remarkable efficiency. The sea cucumber is a detritivore, a consumer of waste. Its mission in life is to clean. It uses its tentacles to sweep the surrounding sediment, gathering up a rich mixture of decaying organic matter, dead plankton, and animal waste, the detritus that settles on the ocean floor like a fine, nutritious dust. It then stuffs these tentacles one by one into its mouth, consuming the collected particles. Other species employ a different, even more direct method. They are the underwater vacuum cleaners. They ingest the sand itself, mouthful by patient mouthful. As the sediment passes through its long, looping intestine, the sea cucumber's digestive system expertly extracts every last bit of nutritional value from the organic film coating each grain of sand. What emerges from the other end is clean, aerated, and biologically stable sediment. In essence, the sea cucumber takes the dirty, used sand of the reef and cleans it, recycling it for future use. The scale of this work is staggering. A single population of sea cucumbers can process tens of thousands of tons of sediment per year on a single reef. They are the ultimate recyclers, preventing the buildup of toxic ammonia and hydrogen sulfide that would occur if this organic matter were left to rot. They are the custodians of the reef's foundation, tirelessly turning over the soil, much like an earthworm in a garden. Without them, the sandy plains would become stagnant, polluted, and lifeless. Its movement is a study in patient, hydraulic grace. It does not swim or walk. It crawls on thousands of tiny tube feet on its underside. These feet operate on a water vascular system, a complex network of fluid-filled canals. By carefully controlling the water pressure in each foot, the sea cucumber can extend it, attach it with a tiny suction cup, and then retract it to pull its body forward. The motion is so slow it is almost imperceptible, a gradual flowing of flesh over the seabed. It is the pace of erosion of continental drift. It is in no hurry, for its work is never done. The sea cucumber's life is one of profound vulnerability, and its defenses are as strange as its appearance. When seriously threatened, some species have a breathtaking, if bizarre, last resort. They perform evisceration. They violently contract their body muscles and expel a portion of their internal organs, their intestines, their respiratory trees, out through their anus. This tangled, sticky mess is often toxic or irritating to a predator, distracting it while the sea cucumber makes its slow, deliberate escape. It then faces the long, slow task of regenerating its lost parts, a quiet testament to its incredible will to live. Despite their unassuming nature, sea cucumbers are deeply woven into the reef's community. Small crabs, pearlfish, and other tiny creatures often live inside the sea cucumber's body cavity, finding shelter in the most unlikely of apartments. The pearlfish, in particular, has a unique relationship, often entering and exiting through the sea cucumber's anus, a shared home that is both bizarre and practical. To watch a sea cucumber is to practice a form of deep observation. There is no drama, no sudden movement. There is only the slow, relentless, purposeful crawl. Its path across the sand is a meandering, polished trail, a testament to the work accomplished. It asks for no recognition. It does not compete for space or beauty. It simply performs its duty grain by grain, day after day, year after year. In a world that often celebrates the fast, the bright, and the fierce, the sea cucumber stands as a monument to the quiet power of the humble. It teaches us that cleanliness is not a glamorous task, but a sacred one. That recycling is not an option, but a necessity for the health of the whole. It is the reef's gentle bulldozer, its silent custodian, a creature that proves that true importance often lies not in how you look or how fast you move, but in the quiet, essential work you do for the world around you. It is a slow, living prayer of purification, a reminder that even the most mundane tasks performed with patience can sustain a paradise. The coral reef is a vibrant oasis, but it is not an island. It exists in a dynamic relationship with the vast blue desert that surrounds it, connected to the wider ocean by invisible, liquid rivers. These are the currents, the great circulatory system of the sea. They are the drifting nurseries, the delivery drivers, and the migratory highways that bring the gift of new life and essential nutrients to the waiting city of the reef. To understand the currents is to understand that the reef does not breathe alone. The warm, sun-drenched waters of the tropics are often remarkably poor in the nutrients, nitrogen, phosphorus, and other minerals that are the fundamental building blocks of life. The reef itself is a masterpiece of recycling, but to thrive it needs a constant, gentle infusion from the outside world. The currents provide this. These great flowing masses of water are set in motion by a complex dance of wind, the Earth's rotation, and differences in temperature and salinity. They can be vast, slow-moving rivers like the Gulf Stream, or they can be local, tidal streams generated by the pull of the moon. But for the reef, their effect is the same. They are a delivery service. They sweep across the open ocean, gathering up a rich broth of dissolved nutrients from the deep, upwelling zones and from the waste products of the pelagic food web. They then carry this life-giving elixir and deliver it to the coral city like a gardener bringing fertilizer to a prized rosebed. But the currents bring more than just invisible nutrients. They are also the great connectors of life. For many reef creatures, their life begins not on the reef itself, but as a tiny, microscopic larva adrift in the open ocean. This is the planktonic stage, a period of incredible vulnerability and profound importance. A newly hatched butterfly fish, a minuscule crab, a baby lobster, each is a tiny speck, a seed cast to the wind of the currents. This is the reef's grand genetic lottery. The currents are the drifting nurseries where these countless billions of larvae spend their first days or weeks. They are carried along, helpless in the flow, at the mercy of the great blue highways. This serves a vital purpose. It prevents inbreeding and allows species to colonize new reefs, spreading the richness of life across thousands of miles of ocean. The challenge for the larva is monumental. It must, after its allotted time adrift, find its way home. It must locate the specific scent, the particular sound, the unique feel of a coral reef amidst the featureless expanse of the open sea. And here, the currents are both its chariot and its map. Larvae have evolved remarkable abilities to navigate these flows. They can move vertically in the water column, rising or sinking, to catch different currents flowing in different directions and at different speeds. They can sense the faint chemical signature of a distant reef, the smell of coral, algae, and other life, and swim towards it. They can even hear the distant collective symphony of the reef, the crackle and pop of the snapping shrimp acting as a sonic beacon, guiding them home. When the conditions are right, a full moon, a specific temperature, a favorable current, the reef witnesses a mass homecoming. This is the settlement, a quiet nightly miracle. The larvae, having completed their epic oceanic journey, will shed their larval forms, sink through the water column, and settle onto the hard substrate of the reef. They will metamorphose, transforming from a drifting speck into a miniature version of their adult selves, ready to take their place in the community. A new parrotfish begins to scrape, a new damselfish claims its territory, a new coral polyp settles down to begin building its stony cup. The cycle of renewal is complete. The relationship is a delicate, flowing ballet. The reef depends on the currents for food and new citizens. In turn, the currents are enriched by the reef, which sends its own larvae and organic material back out into the blue, contributing to the pelagic system. It is a constant, reciprocal exchange. To float in a gentle current along the reef wall is to feel this connection viscerally. You are not just in the water, you are in the flow. You can feel the ocean breathing around you. You see the soft corals and sea fans, their branches perfectly oriented to intercept the passing nutrient river. You see the fish all facing into the current, waiting for the food it brings. The entire reef is positioned in a state of serene, receptive attention, like a congregation waiting for a blessing. The currents are the reef's lifeline, its link to the world. They are the silent, powerful force that ensures the oasis does not become a closed, stagnant pond. They are the bringers of food, the carriers of children, the messengers of genetic diversity. They are a reminder that no ecosystem, no matter how magnificent, is truly isolated. We are all, like the reef, connected by invisible currents of water, of air, of life, receiving and giving in a slow, eternal, and deeply peaceful dance with the wider world. On most nights, the reef settles into its nocturnal rhythm, a world of quiet hunters and filter feeders under a blanket of stars. But there are certain nights dictated by the ancient silent clock in the sky when the reef erupts in a silent underwater blizzard of life. This is the mass spawning event, one of the most breathtaking and serene spectacles in the natural world. It is the reef's collective act of faith, a synchronized release of eggs and sperm into the sea, all conducted under the gentle, silvery lullaby of the full moon. The timing is not left to chance. For months the corals have been preparing, their bodies swelling with the developing gametes. They are waiting for a perfect fleeting combination of cues, the warmest water temperatures, the specific phases of the moon, and the precise time after sunset. This meticulous synchronization is a survival strategy of profound elegance. By releasing their eggs and sperm all at once, the corals swamp the predators. They create a vast, overwhelming soup of potential life, so dense that even the most voracious appetites can only consume a tiny fraction. In this numbers game, enough gametes will survive to meet, unite, and begin the next generation. The event often begins with an almost palpable sense of anticipation. As darkness falls after a full moon, the reef seems to hold its breath. Then, one by one, and then in growing multitudes, the coral polyps begin to participate. Each tiny polyp, looking like a miniature flower, will slowly extend itself further than usual. At its tip, a small colored bundle becomes visible. Some are pink, like tiny rosebuds. Others are orange, yellow, or creamy white. These are the gamete bundles, each containing both eggs and sperm, a tiny, self-contained promise of life. The release itself is a slow, mesmerizing eruption. The polyp seems to sigh and the bundle is gently let go, floating upward from its stony cup. It is not a violent expulsion, but a serene surrender. Within minutes, the entire reef is participating. The water thickens with a slow, reverse snowfall, millions upon millions of pearlescent bundles drifting languidly toward the surface. They rise like constellations being born, a galaxy of life ascending in the still water. The scene is one of breathtaking beauty and profound peace, a silent, celestial dance. This is the moon's lullaby. The lunar cycle, with its predictable rhythm, is the conductor of this symphony. The moon's gravity pulls the tides, but its light also provides the signal. The corals, along with many other reef inhabitants like some sponges and worms, have evolved to read this celestial calendar with impeccable accuracy. The full moon provides just enough light to synchronize the event across vast distances, ensuring that corals from one end of the reef to the other release their bundles at the same time, maximizing the chances of cross-fertilization between different colonies. This genetic mixing is the key to the reef's resilience. At the surface, the magic continues. The bundles, buoyant with oils, float and begin to dissolve. The sea takes on the scent of fertility, a mild, cucumber-like aroma. This is the moment of conception. Eggs and sperm from different colonies mingle and meet. Fertilization occurs there, at the interface of sea and sky under the watchful eye of the moon. Each successful union creates a tiny, ciliated larva known as a planula. This new life, the result of the reef's great collective effort, now joins the drifting nurseries of the currents. It will spend days or weeks adrift, a tiny voyager at the mercy of the ocean before its own internal instincts guide it to seek out a hard, sunlit surface upon which to settle. It will then undergo its final metamorphosis, attaching itself permanently and transforming into a single polyp, the first founder of a new colony, the first dreamer of a new coral city. To witness a mass coral spawn is to be humbled. There is no sound, only the visual spectacle of billions of lives being tenderly released into the unknown. It is not an act of frantic desperation, but one of serene, coordinated trust. The reef is investing its future in the ocean's embrace, trusting the currents to carry its children, trusting the moon to guide the timing and trusting in the sheer, overwhelming power of numbers. It is the ultimate expression of hope. A single coral polyp, barely a centimeter tall, participates in a global ritual that has been repeated for millions of years. It is a lullaby sung not with sound, but with light and life. A gentle, rhythmic pulse of renewal that ensures the reef's song will continue. Under the quiet gaze of the full moon, the reef gives itself to the future, a silent, beautiful promise drifting upward on the tide. From the vantage point of space, our world is a swirling marble of blue and white, a planet wrapped in a liquid mantle. This vast ocean is not a uniform soup. It is a complex, dynamic system of currents, temperatures, and life. And within this global system, coral reefs play a role far greater than their modest footprint would suggest. They are not isolated oases, but vital beating hearts that help regulate the health and chemistry of the entire ocean, influencing life from the sunlit surface to the abyssal plains. The first and most profound role of the reef is as a great carbon sink. The ocean is the planet's primary regulator of carbon dioxide, and reefs are one of its most efficient engines for sequestration. As corals, coralline algae, and other calcifying organisms build their limestone skeletons, they are, in essence, pulling carbon out of the water and locking it away in solid form. The process of calcification is a slow, steady drawing down of carbon, which is then stored for millennia in the massive carbonate platforms that form the reef's foundation. When a parrotfish crunches coral and excretes it as sand, that carbon remains locked in the sediment. In this way, the reef acts as a biological pump, helping to moderate the amount of CO2 in the water, and by extension, the atmosphere, contributing to the global climate's delicate balance. But the reef's influence extends beyond carbon. It is a master of nutrient cycling. The warm tropical waters where reefs thrive are often nutrient-poor, akin to aquatic deserts. The reef ecosystem, through its breathtaking efficiency, creates abundance from scarcity. It captures and tightly cycles the nutrients that flow in from the currents and from the marine snow. The waste from one organism becomes the food for another in a rapid, closed-loop system that prevents these precious nutrients from being lost to the open ocean. This intense local productivity creates hotspots of life that radiate outward, supporting pelagic fish and mammals that live in the blue water beyond the reef's edge. Furthermore, the physical structure of the reef itself shapes the coastal environment on a grand scale. The Great Barrier Reefs of the world, like their namesake in Australia, act as massive breakwaters. They absorb the immense energy of ocean waves, dissipating their force before it can crash upon the shore. This protection safeguards fragile coastlines from erosion, creates calm lagoons that serve as nurseries for countless species, and ensures the survival of mangrove forests and seagrass beds, which are themselves critical coastal ecosystems. Without this living buffer, many tropical coastlines would be reshaped, and low-lying islands would be far more vulnerable to the sea's power. The reef is also a global reservoir of biodiversity. While covering less than 1% of the ocean floor, they are home to an estimated 25% of all marine species. This makes them not just cities, but libraries of genetic information. The wild array of life forms, from the simplest sponge to the most complex predator, represents millions of years of evolutionary innovation. This biodiversity is a source of resilience for the entire ocean. When environmental conditions change, this genetic library holds the potential for adaptation and survival. The chemical compounds that reef organisms have evolved for defense, communication, and competition have also become invaluable to humanity, providing templates for new medicines, from painkillers to cancer treatments. The health of this blue mantle is inextricably linked to the health of its coral hearts. When reefs bleach and decline due to warming waters, their ability to sequester carbon is compromised. When they are damaged by pollution or physical destruction, their capacity to cycle nutrients and protect coastlines diminishes. A sick reef cannot perform its vital planetary functions. The consequences then ripple outward. Declining reef health can lead to reduced fish stocks in distant waters, increased coastal erosion thousands of miles away, and a reduction in the ocean's overall capacity to buffer against climate change. To see a reef, therefore, is not just to see a beautiful underwater garden. It is to witness one of the Earth's vital organs at work. It is a kidney filtering and cycling nutrients. It is a lung helping to regulate atmospheric gases. It is a heart pumping life and energy into the wider ocean. It is a skeleton providing the structure upon which immense coastal ecosystems are built. We live on a planet wrapped in a blue mantle, and the coral reefs are the intricate, shimmering threads that hold parts of it together. They are a testament to the fact that the smallest actions, the building of a tiny polyp's cup, the crunch of a parrotfish's beak, can, when multiplied by billions and over millennia, shape the very character of our world. They remind us that the ocean's health is our health, and that in protecting these vibrant living cities, we are not just preserving beauty, we are safeguarding the fundamental processes that sustain life on our blue planet. They are the quiet, persistent guardians of the sea, and their silent, steady work helps keep the entire world in balance. In the end, even the mightiest coral city is not eternal. Storms will rage, sea levels will rise and fall, and the slow, patient work of countless organisms will continue its gentle demolition. But on the reef, an ending is never truly an end. It is a transformation. The same forces that build the complex, living fortress of the reef are also the very forces that dismantle it grain by grain, recycling its substance into one of the most iconic symbols of peace and tranquility on Earth, the pristine, white sand beach. This is the eternal cycle of sand and stone, a serene and beautiful reminder that in nature, loss and creation are two currents in the same endless flow. The process begins even as the reef thrives. The parrotfish, as we have learned, is a primary architect of this change. Its rhythmic crunching is the sound of the reef's solid past being ground into its powdery future. With every bite, it takes the hard, complex structure of a coral skeleton and, through the mill in its throat, reduces it to a fine, white sediment. What was once a protective cup for a polyp becomes a soft, yielding grain of sand. A single parrotfish can produce over 1,000 pounds of this sand each year, a constant, gentle snow of sediment that drifts down from the feeding grounds to settle in the calm lagoons. But the parrotfish is not working alone. It is joined by a guild of other eroders. The sea urchin, with its 5 ever-growing teeth, scrapes meticulously at the rock, filing it down. Boring sponges and clams drill tiny holes into the limestone, weakening the structure from within. Even the waves themselves, crashing against the reef for millennia, act as a slow, powerful mortar and pestle, breaking down larger pieces of coral rubble into smaller and smaller fragments. The reef is in a constant dynamic balance between the upward growth of the corals and the downward pull of this relentless, patient erosion. This newly created sediment does not simply vanish. It is carried by currents and waves sorted by size and weight. The finest particles may be swept out to sea, but the larger, coarser grains of sand accumulate. They fill in the spaces between coral heads, creating the vast sandy plains and lagoons within the reef complex. These sandy patches are not barren wastelands. They are essential habitats for garden eels, gobies, sand-dwelling sea cucumbers, and countless other creatures adapted to a life half buried. And then the Great Migration begins. With every high tide and storm surge, a portion of this sand is lifted and carried shoreward. Wave by wave, grain by grain, the reef gives of itself to the land. Over centuries, this slow, persistent donation builds up the dazzling white beaches that fringe tropical islands and continents. The very sand you wiggle your toes into on a tropical vacation is, in large part, the processed remains of a coral reef. It is a beach made of memories, each grain a tiny, sun-bleached fossil of a once living animal. This is the reef's most profound and final gift. The beach it creates becomes a new ecosystem, a different kind of sanctuary. It is where sea turtles, guided by the same moon that cues the coral spawn, haul themselves ashore to lay their own future in the warm sand. It is a resting place for seabirds and a nursery for shorebirds. The calm, sheltered waters behind the reef, created by the reef's own physical presence, allow for the growth of seagrass beds and mangroves, which in turn stabilize the coastline and provide yet more critical habitats. The cycle is a closed loop of breathtaking elegance. The living reef builds with stone. The reef's inhabitants, through the simple act of living and feeding, break down that stone into sand. The ocean's energy then delivers that sand to the shore, creating the conditions for new life to flourish. And in the long geological view, that sand itself may one day be compressed back into limestone, or submerged by rising seas to form the foundation for a new reef in a future age. To understand this cycle is to see the reef not as a static monument, but as a flowing, breathing entity. It is a river of calcium carbonate flowing from the water column into the bodies of polyps, becoming stone, then being transformed into sand, and finally coming to rest on a sun-drenched shore, only to potentially begin the journey all over again. There is no waste in this system. There is only change. There is only transformation. This is the deep, abiding peace of the reef. It teaches us that endings are illusions, that what appears to be a decline is often a necessary phase in a larger, more beautiful process of renewal. The reef in its passing does not die. It simply changes form. It becomes the soft bed upon which a new generation will rest. It becomes the powdery canvas for the tracks of a turtle. It becomes the warm, white expanse that embodies our dreams of paradise. So, the next time you stand on a tropical beach, feeling the fine, warm sand between your toes, remember the great living city just beyond the horizon. Listen for the distant, rhythmic crunch of the parrotfish. Think of the tiny polyps that built their castles of stone, and know that you are standing on the peaceful, beautiful aftermath of their long, patient labor. The reef gives us not only the vibrant spectacle of its life, but also the serene legacy of its transformation, a perfect, eternal cycle of sand and stone.